Hi everyone, I'm Leah. I'm a test automation and DevOps engineer who is keen on analyzing daily scenarios and trying to make some changes. I'm really excited to be here today because so many excellent speakers, organizers, testers, and developers are here. I'm proud to give my first public tech talk in RoboCon 2023 online. Today my talk is about knowing your robot. It's always not an easy task to know your code base well as the test cases are growing so fast. But knowing your own robot framework code base will definitely help you to keep the code cleaned, from which a long-term development can always benefit. First of all, I would like to introduce our test scenario. Our target product is an application software which runs on local client machines and communicates to our server. There are two kinds of products: standard for personal users and enterprise for server-client architecture. When a new feature is finished, the new package will be generated and installed in our test environment. Then smoke tests, acceptance tests, end-to-end tests, and so on will be executed, and test reports will be generated. What adds up the complexity is that the keywords from different sources, here the B2B and B2C editions, may have the same keyword name, but they will have different contents because of product dependencies. Before our test automation, the development and testing are more like a waterfall model. The test definitions may come parallelly with the development, but the test execution will always in the end. After introducing Robot Framework, the test definition and test scripting become more or less one stage. When the QA tester is writing the test definition, the test automation engineer can also parallelly start the scripting, and the test execution will be done by the CI/CD pipeline. The result will be showed in the monitoring tool and displayed and notice our developers, so that the issue can be tracked more frequently and the bug gets fixed more quickly. As mentioned in the previous slide, because of the different editions, there are keywords with the same name but used for different editions with different content. So the directory structure gets more and more complicated. Slowly, we find that we gain more and more tech depth. The number of the test cases grows. The size of the code base also grows. However, there are many duplicate keywords with different names but use almost the same. We may refer to some wrong keywords or insert typos and never recognize it before the whole test suite was executed and failed, which takes a lot of time. And coming new joiners, they have no knowledge about which keywords were already written which keyword can be used for my use case. So more and more duplicate or similar keywords were created. So what do we want? What do we expect? Of course, we would like to have the code clean and light. I hope the keywords can be reused easily, which means the existing keywords can be searched and found and to be recognized what they are for. I hope keywords are unique for their usage, so no more duplicate keywords with similar but different names. I hope the conventions are kept, so the naming of the keywords should be under the same standard. I hope the coding errors can be recognized early, so that I don't need to wait to execute the whole test suite to recognize my typo. It's hard to achieve, but we can figure something out. We need to build an overview of all customized and library keywords, as well as their relationship with the test cases and test suites. Also, the dependencies between the resource files are also needed. Otherwise, we don't know which keyword is used by which test case. One solution is to store the keywords and test cases as well as the resources into relational database. To achieve that, we need to scan the whole robot framework code base. In the first scan, all keywords will be scanned and stored to the table base nodes. So you might see the row includes keyword name, path, documentation, and last change time. After this run, each keyword which is customized will get an ID. And now we can do the second scan. The second scan will be for all the keywords and test cases files. For each keyword, the parent if the child keyword is not in the base nodes database, it should be generated and one record should be written to the parent nodes. When the keyword already exists in the base nodes, then in parent nodes, the road can directly take the ID of the existing keyword ID in base nodes. In this way, we can store all the keywords and test cases and retrieve their tree dependency. Besides, what we still want to achieve is to search for existing keywords and find out wrong keywords based on the resource file dependencies as well as if the keyword exists. So this two goals, we can achieve it by using SQL query in our robot database. And the last goal is to find out duplicate keywords with the similar usage and reduce them. For this purpose, we will use a fuzzy search such as tree-ground search. To implement it, we need to first install the extension pggram and then generate a gene index, which is a generalized inverted index for our database. And then find out in the basic node, which means the table of the keywords, which keywords are actually similar to each other in naming. Another possibility would be to use a non-relational database, such as MongoDB or Elasticsearch. They are designed to handle large amounts of unstructured data, including hierarchical data, and they can store large and complex tree structure data as nested documents, making it easier to represent the relationships between nodes. Non-relational databases are well suited for applications that require fast and flexible data retrieval. When the test codebase continually grows, then the dataset might be so large that the non-relational database will show its advantage. In this example, we can see how we can store the test case and the keyword in the parent-child module in 3 documents in the same index in Elasticsearch. After declaring this prototype, ideas, principles, we still have a long way to go. It's important to improve the graphical user interface so that the tester will have a better user experience. And it's also important that we can test on a larger test plans to compare the solutions with relational and non-relational database. What is also ongoing is the integration of our test database with a test management system such as TestRail or X-Ray. So that's all for my talk. Thank you so much for your attention, and I really appreciate it. And now I'm willing to answer any coming questions.